Hello friends, welcome to the day 16 session. Today we are going to see the other operations of a pandas. So that is hierarchical indexing. So before jumping to the today's session, let me just brief out the yesterday's part. So we have been just started with the pandas. So how to install the pandas? See how to use the pandas packages. So these are the things we have been just started with. So so this pandas is a extended version of NumPy. It can handle multi-dimensional data. So it can have both the labels and it can have both the features. So it can have a heterogeneous data, whereas in NumPy they were using only the same data type. So if you are entering the values of a data set or array values, that should have a same data set. So if you are entering int, you should follow int. So you cannot enter a char and all. So that was the another advantage of using pandas. So the pandas were using for storage accessing, and it has been built above the NumPy. The main thing is it is going to handle the missing data. So next we have been seeing how to use a pandas and how to install it. So installation is same, pip name, pip install package name, and import pandas as PD. So next the fundamental structure, series, data frame and index we have been just seen with. So how to create a series, how to create a dictionary of series, and we have been just created some of a data set of populations of state 5 states with a population and area, and we have been just performed some of our operations on it. So this population and area have been created by using the series on dictionaries, and we have been computed a what is this population density by dividing population divided by total area of that respective state. So handling the missing data. So wherever the missed data has been just provided, we were having some of the functions like is null, not null, drop NA, fill NA. So is null means wherever the NaN is there, true is going to come. So not a null means inverse of it. So drop means you are going to drop the entire row. So entire row and column if you are having NaN value using this drop NA. Fill NA is like wherever not a number is there, you can fill with your respective numbers. It can be 0, it can be 1, it can be any user defined value. So detecting the null values. So dropping the null values we have been just seen. So detecting is like is null, not a null. So here drop NA, it can be done by using columns and rows. So here for creating a data set you need to use data frame, not a series. So filling values. So as I told you earlier, you can fill the values with specified number. So today we are going to start with hierarchical indexing. So till now we have been just seen only 1D, 2D format. So now we are going to access the multi-dimensional. So multi-dimensional means you will be having more number of rows and columns. So this is multi-dimensional issue. So here again we are going to take states with a population. So next or state name with a year, in which year the respective state name, and in that year what is the population. So we are having a 3 values here. So here we are going to just use a multi-index in order to create a hierarchical indexing. So we can just so one thing you need to understand here is you can go in depth, you can have some of our respective operations on multi-dimensional data, so using pandas. So we can just see one of example of it. Okay, then I'm just starting with the index. So index will be equal to, so I am taking a state 1, or you can go for any of a name of a states. So that too in a year 2000 I am speaking. And again the same state in 2010. Okay, it should be in small brackets, inside a small brackets. So everything should be inside a small brackets here. So next I am taking another state here. So any of our state name in India. So this is the same thing in 2000 and the same state value in 2010. So in the same manner, I'm going for another state value in 2000 and the same state value in 2010. So this is like a index value. So now I am going for a population. So populations will be provided with respective year. So these are all the general numbers. Just writing for an assumption sake. Okay, this is for second state. Okay, I forgot to write comma here. So the third state. Okay, these are all just general numbers. Now I am using pop pd dot series. So series, what I am doing is I am having populations what I have been created here, and I am passing a index value for it. So index will be what we have been just created. So if you are getting confused, the variable name you can just change it to index 1. So the index value is index or this one for Karnataka in 2000, this one. So 2010 for this one, and the next state Kerala in 2000, this one. So like this Andhra. So these are the index value accessing. So now we are just having a population here, and I am accessing the state with a respective year. So till Karnataka to of year 2010. Okay, there is some type mistake here. So to Andhra for year 2010. Why it is showing error? We can just see it what is the error it is coming, or if it is not an error we can just proceed. Okay, it's better to just have a brackets maintenance. If you are just skipping any of one of a bracket, it will just generate errors. So here it is going to have a states starting from Karnataka to Andhra. So this is being just listed here. So you can just see what are all the areas which have been just done with. So now, so we have been just listed all the states have been just provided with an year, with a specified years. So now we are just going for accessing all specified year. See, like 2010. So here we have been just seen all the years here. So started from Karnataka 2010 to Andhra 2010. So now we are having, so if the application is like accessing the specified year, from specified year we need to just have a printing of a value. So during that case you can just use these kinds of a syntax here. So I, for I in bob dot index 1, if I of 1 is equal to specified year. So this is a thing. For accessing or specified year. So this was just like a general, starting from this without checking any condition, go further. So you can just see the respective syntaxes here for accessing object as not having an index 1. Okay, so index is this one. So here we have been specified the year, that is 2010. So if the condition of I value is equal to 2010, why this one has been taken is, so the 2010 will be at the second position of a first state. So first state Karnataka is having two entities, 2000 and 2010. So here, so first one will be the state name. So the second position will be the year. So if this year is equal to 2010, then access both the values of the state name and what is this year with the respective population. It is going to be accessed. So here you are having multi-dimensional array. Inside that multi-dimensional arrays, you are operating on several indexing. So based on the conditions as well, you are just working on it. So the next one is like, so this was a manual working. So let us see how the pandas is going to help for doing the multi-dimensional accessing. So index 1 pd dot multi index dot from tuples, and you are passing index. So what is the disadvantage of using this for loop is like it takes time. So it takes time for having a, if a data set is too much big, if data set is big, then the time taken for doing this step, so this step is going to be comparatively high compared to the this pandas version. Why? Because it need to access each and every block. So each and every blocks need to be analyzed to check with this condition. So for accessing it need time, for checking also it need time. So now we can just see how this hierarchical index is going to be just helpful for having the population. So you can just see here, we have been just provided with a respective multi-index from tuples. So here we have been just passing the index 1 which have been created here. So from multi-index we are accessing a tuples here. So tuples have been just declared with the smaller brackets. So index is going to be accessed. So you can just see what are the index values here. So like this, you can just proceed with. So next, in what you have been just seen in the basics, by using pandas also you can just have a slicing method. So like slicing means say like having a year. So this one. So with the respective year, this values are going to be sliced with a respective state name with the respective years. So 2010. So this is also another operations which you can just carry on a pandas. So the next operation is like okay, let me take a pen here. So this unstacking, so converts, so it is used to convert the series to indexed data frame. So indexed data frames means, so for every value or every series, some number will be provided. So series to indexed data frames. So this is a working of, what is this? Unstacking. So stacking is a one which is going to convert from, so this is unstacking. So from data frame to series is called stacking. So this is a respective versions of stacking and unstacking. So we can just see it as an example. So here we can just create a database of pop.unstack. So here we are just using a unstack operation. So you can just see unstack means convert from series to indexed data frame. So population was having in series pop. So now you are converting the series to data frame. So you can just print it. So print population in data frame. Okay, you can just see what is the execution. So the series was like instead Karnataka and all. So it has been converted into a data frames now. So the difference between series and a data frames is like, in data frame we can access rows, columns, we can just differentiate like differentiate between labels, features like this. So this is a usage of a data frames, and in data frames we can just handle the missing data. So if any of a data is not a number here, you can remove it by using drop NA. So that is a major issue. for converting the data set into data frames, that is series to data frames. So now you can just use a stack operation. Pop.df is being converted into a data frame. Now you can convert back the data frame into a series. So this is the versions of converting back from what is this data frame into a series version. So so why we need this hierarchical indexing is like whenever we are going to represent the 2D in 1D dimensions. So the 2D means having both rows and columns. So if you need to convert this 2D into 1D, then we need this hierarchical indexing. So why we need to convert this 2D into an 1D means, so the primary step in machine learning is to convert all your images or data set into an vector format. See, consider if it is having 28 cross 28. So 28 into 28 is 724 something value. So this multi-dimensional data, that is 28 cross 28, should be converted into a single vectors. So again, if it is a color image, 28 cross 28 into 3, 723 into 3 value. So that is 2000 or 21,000 some digital values, some digits value. So 1 to 21,000, a single array need to be created. So in order to do that, we are going to use this hierarchical indexing. So that was a need of hierarchical indexing for representing 2D data in a 1D series. So next one is like you can add the column to the existing data frame. So this was a existing data frame here. So I am just adding the columns for this, for an existing data frames. So data frame, data frame. So I am just adding another value called total, and I am pushing the pop for it, and I am just adding a new column here under 18. In this total population, how many are under 18 populations? So again, I am just writing a numbers here. So how many states were 1, 2, 3, 4, 5, 6. Okay. Just a rough numbers. It is not accurate numbers. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So this was the initial population. Okay, you need to close this. Open bracket, close bracket. Fine. So take care of a brackets, opening and closing of a brackets. So you can close it at a final itself. So total column is population. So population of each states. In that we are adding a new column here. So this is like for an existing data set, some new column is going to be added. So you can just print it. So you can just give it as a new. So print pop data frame new. So you can run this. So under 18 new column is going to be added. So this is a total population. this total population under 18 is this much of populations. So this version is like how to perform the stacking and unstacking, and the next one is like adding columns to the existing data frame. So that is what we have been just seeing. So next comes concatenation operation. So before this we are having another operation like combining the data set. I have been just forgotten to add that slide. Combining data set. So you are going to combine the two data set. So using pandas and by using respective numpy. So you are using these both frameworks to just combine the data sets. So for combining, we are using an operation called concatenation operation. So how this combining is going to be carried out in NumPy, and how this combination or concatenation is going to be carried out in pandas. So in pandas we are having more options. So the what is this the program or a function name to perform concatenate is pd. So small pd dot concatenate. So this is a variable you are going to concatenate. You are having an axis is equal to 0. So axis is equal to 0 means you can have a concatenation in row wise. You can make it as 1 for columns. So you can join the outer version, join axis is none, ignore indexes, false. So keys is equal to none. You are having too many options here. But whereas in NumPy you are having very lesser operations, and you are having only a simple operations using a NumPy. So we can just see those things. So concatenation, I am just taking some list here. So x, y, z. So now I am going to use a NumPy. Okay, whether NumPy is imported. Okay, I am using a concatenation operation. So concatenate, and I am just passing the variables names here x, y, z. So this is like how to perform a concatenation operation. You are having one of a feature in NumPy also. So in concatenation, you can have the x-axis. You can add both the x-axis. See, like addition, and you can just mention where you are going to add that, in columns or in a row. So 1, 2, 3 is available. So whenever you are going to concatenate the same value in column wise, so 1, 2, 3 and next column, we can just see how it is going to just work with. Okay, let me just print these values first. Okay, we can create another index. It may just confuse with having a row. So this is first multi-dimensional matrix. We are concatenating these three values. There is another option like you can have the multi-dimensional data like this x1. So it is having 2 rows and 2 columns. So I am just adding it for a extra column. So these values are going to be added. So this is the columns which are going to be just added in a next version. Okay, the syntax, you can go for np.array and you can just create this respective arrays. Let me see. Okay, np is defined unresolved np. So we are just creating, to avoid a clumsiness, I am just made with a new file here. So np.concatenation operation we are just going to perform. Another bracket is missing here. So here again I am just printing the np dot concatenate. I am using the two matrices x1 comma x1, and where it need to be added, the new x1 is need to be added in a column wise. So this is a, you can just see before executing this, I will just explain what will going to be happening. So this was a concatenation of x, y, z. So it has been added. So three different matrices, it has been merged. So this is a matrix of 2 rows and 2 columns. So after executing this, so the same matrix will be printed along the axis of 1, that is to the columns. So to the columns it will be added. So 1, 2, 3, 4 is a first matrix. So along column it has been added the new values, that is new x1 values. You can just change it to row. You can just see how it is going to be just changed with. So you can just see 1, 2, 3, 4 was earlier version. So the new x1 or the same x1 has been just added here. So this is all about having a concatenation operation in, what is this, NumPy. So how to do the concatenation operation in pandas? So let me take a D1 data set. So I am using pd.series and I am having a data sets here, B, C, and we are having an index value of 1, 2, 3. So in the same manner, we can have the data set 2. So data set 2, you can change the values. So the index also we can just change to 4, 5 and 6. So one after the other. So now we can just observe how this concatenation operation, concat, you are going to concat the both D1 and D2, and you are not using any of those optional values. So you can just see the difference between the concatenation which is going to happen in NumPy and pandas. So here we are having an index. Whenever the index is going to be present, we can access it. So accessing is going to be happening at a easier task. Why people will stress on accessing is like if you are having 10,000 data set, if you are using NumPy for concatenation, everything will be mixed. It becomes like one like mudde. It becomes a mixture. You cannot just differentiate any of the things. So during the state, if you are using a pandas, so you will be generating a index values. So this was all about how to concatenate a respective version. So next we will just jump in to the next topic. So what is the next one? So how to read a CSV file into Python. So CSV file means it is a data set file. So you can save the supervised type data set or unsupervised type data set. So now I am taking a supervised data set, the two of hard disk one. So let me show you that data set first. So it is okay. Sorry. It is not a hot disk data set. It is like a house value data set. See, like the price of our houses. So that will be the data set which have been just chosen. I'll be just showing that how to just have a data set values and how to make it feasible. So this is a data set which have been used. It is having some real-time data set. It is having a rows of 18,397 and it is having a columns of how many columns we are having? 21 columns. So it is going to give you the price of a house. So like what is the price of a house based on the requirement: bedroom, bathroom, car, parking facility. They are not going to give cars. Parking facility, land size, where in the respective location, what is the longitude and latitude, and this is a Melbourne city's data. It is not a India's one, it is a California city's, Melbourne city's data. So now how to take this data set into a pandas. So first you are having two versions. First thing is you can copy and paste into your respective working directory. You can copy and press Ctrl V here and it is going to be pasted. So this is a one sort of taking a data set, or else you can give the direct link of that respective data set where it has been just seated. So I am taking a real-time data of house price. So here I am using a pandas and I am using a function called read_CSV. So CSV means in which format it has been just stored. So CSV means common data, so that is commonly separated data values. So you can just see what is the full form of it. So I am just passing the name, function name here, or a file name, Melbourne data, and that is in an CSV format. So you can just see what is the full form of it. Common data delimitation or something like this. So commonly delimited, CSV means common delimited data. So here you will be having several of a thing. You need to select common delimited. So we are taking into an respective version. So now see, like we are having some of the features here. So these are all the features. So it is having on a total of what is this, 16 or 15 features. So starting from here, or you can just go for this one. So we are having 13 features. Out of this 13 features, if your requirement of a customer is based on the bedrooms, bathrooms, car facility and all, you can access it by using a slicing operator. So what we have been learned till now, it can be used on a real-time data set. So now I am just taking a data set here. So we are using a Melbourne data. So we are having a data set here. We are just dropping some of our non-zero values. So this was a version what we have been just used. So access is equal to 0. That is, wherever the NaN is present, you need to drop whole row. So if it is 1, it is a, you are going to drop the whole column. So wherever the NaN have been provided, that whole row is going to be deleted. See, like whenever we are collecting a data like 18,000, if this number have been missed, instead of confusing to the machine, this whole row is going to be just deleted after executing this respective line. So now I am taking two values, x and y. In x we are having a features, in y we are having a prices. So in x we are having a data set here in this data. So after this, okay, now let me just have a y first. So y equals to data house dot, I am accessing price, only price. So here is a price. So it has been available in an sum of a variable. In this variable I am accessing price and it is being seated in y. So I am making a supervised version. So price and labels. So in x I am not interested with taking all the 13 features. I have been interested with taking only few selected features. So now I am just deciding some of the features. So I have been interested with only taking rooms, and while typing here the name should be same. So the name or a column name should be same here. You can just take care of it. I am just going for rooms, bathrooms. So you need to go for C, bathrooms. Next, you are interested with having land size. Okay, out of 13 I am taking some of other values. Land size. Okay, land size. Next, that's enough. So that is the features. So out of 13 I am accessing only this much of data. So I was having 13 full features. In this 13 features, I have been accessed only the rooms, bathrooms and land size, and it has been available in house data house price. Data house price is going to hold this Melbourne DT CSV. So this file, in this file we have been dropped the non-zero row. So if you are having any not a number, then that row is going to be deleted. Out of 13 we have been accessed only, what is this, respective 3 features. You can just print all these values. So first you are printing the data house, next you can print X, you can print Y value here. So this is price and this is features. You are preparing a supervised data. You need to remember what is supervised and what is not supervised. You are having a very good what is this functions in pandas. You can just have this head and describe. So describe means it is going to analyze the data set and it is going to generate what is the description which have been available for your respective data set. Heads means what are all the heads here. So these are the heads will be displayed, and describe means what is the data set actually having. So let me just explain what this machine is going to understand the data set and it is going to describe on its own. Okay, it will take some time. Based on the system speed, the time variation is going to be varied. Okay, no such file is found. Okay, you can just give a link if it is not working. Okay, you can have in any of our folders and you can give a link of it. Okay, bathrooms. Bathroom, only bathroom is available. Okay, if the name is not provided like this, it is going to generate errors. Okay, now you can just see like what is this is. First I have been printed a data house price. So this is data house price. Later I have been just taken only rooms, bathrooms and land size. So out of this 13 features I have been taken only 3 features. So that is X is going to be just printed here. So then I have been just printed only the prices here. So this is a price. So next we need to just print this describe and you need to just go for head printing. So as I told you earlier, the heads means data set heads. So here comes the description. See here in an rooms column, or let me just take a bathroom column, what is the count of non-zero value? So this is a non-zero value count in rooms, bathrooms and land size. What is the mean value of it? Inside this 18,396, what is the mean value? So mean value means the respective rooms are 2, bathroom 1 and land size value. Standard deviation of out of this values. Minimum value is 1. So minimum room is 1. So 25% of this one, 50%, 75%, maximum rooms is 12, and bathrooms maximum number is 8. So this is like, it is going to describe the data set on its own. It is not taking the help of a human being. We are just giving a data set. It is going to analyze what is the count value, what is the mean value of it, standard deviation, minimum rooms, maximum rooms. 25% of this data sets rooms is having these many rooms and these many bathrooms. 75% rooms is 3 and 2 bathrooms. So like this. So this is the respective analysis of a machine on its own. So the next one is x dot head. So heads means we are having only these many heads: rooms, bathrooms, and land size. Why? Because we have been accessed this features, and this is the method for usage of pandas on a real-time data set. So this is a real-time data set. So if we are using any of our classifiers here, then we can predict the house of a machine if we are giving these many inputs to the respective model. We can just see that in the next classes once we are going to touch the classifiers, that is machine learning core. So that's it for this video, guys. I guess these sessions are informative. We can just continue the sessions in next videos. Thank you. Let's meet you all in the next video. Thank you.